Hello, my name is Preston Robinette, and today I'll be introducing our artifact neural network malware detection verification for feature and image datasets. This artifact is part of our research that explores how formal verification can enhance the robustness of neural network-based malware detection systems. Let's go ahead and get started. Recent work on malware detection relies on deep neural networks. In order to train these networks, of course, we need data, which typically comes in two forms: malware feature datasets and malware image datasets. And the two main use cases for these classification networks are to classify in the binary sense whether a piece of software is benign or malicious, or once detected, what family the malware belongs to. Machine learning models are increasingly used for malware detection, but they remain vulnerable to adversarial attacks or small perturbations in data that trick models into misclassification. Our work focuses on verifying the robustness of these models, so ensuring that adversarial perturbations cannot cause misclassifications. This is critical for making malware detection systems more secure. Our artifact consists of two main phases. In the first phase, we look at model training. So we train binary models, so looking at models that classify whether a sample is benign or malicious, and we do this by training on feature dataset BODMAS. For the second class of models, we look at family classification, and here we train on the image dataset malimage. So these trained models are then used as inputs for the verification phase, which also takes as inputs specifications, which we use to test the robustness of the trained models using verification tools. The verification tools used in this work are NNV as well as NNenum. NNV requires a MATLAB license, and NNenum is just a Python-based tool. So for the examples later, we'll just be looking at NNenum. From these tools, we gather certified robustness accuracy as well as time to verify metrics. And CRA is telling us how robust a trained model is towards a specific specification. So as a result of this artifact, we received the available badge as well as the functional badge. So let's go ahead and start looking at the code. So this is the landing page for our artifacts. The initial part is just looking at files that are contained in the artifacts. In here we have a README which describes how to use the artifact as well as how to install the artifact and the scripts needed to produce specific results from the paper. So first, looking at the requirements, we require Docker, a MATLAB license. MATLAB license is only required for the NNV parts of this project. It can still be run for just NNenum though, which is a Python-based tool, as well as approximately 20 gigabytes of disk space. For the installation process, we're simply going to clone this repository. And as you can see, this is the GUI version of this. We have downloaded that repository and it looks the same. Next, we are going to download the datasets from here. So just to verify that the archive has all the files that it needs, we are going to run ls archive. Oh, those are still downloading. We can also check here. And they're finishing downloading there. So while we're going to finish downloading, the second part of this artifact are the smoke tests. So a smoke test is just an initial test to see if the setup was successful. This specific smoke test, utilizes NNV as well as NNenum. Because we're only going to focus this on the NNenum aspects of this artifact, I'm going to scroll down here and utilize this smoke test. So here, we are going to let this run. Know that everything is installed correctly. So we're going to exit out of this. Now the next part of this artifact would be to run the entire artifact to reproduce every single result from the paper. And to do that, we would simply copy and paste this particular code. Once that completed running, it takes about 2 hours to run. All of the artifacts would be copied into this particular repository. Our artifact is very comprehensive. It allows a user to be able to reproduce every single artifact from the paper, and it's very user-friendly and intuitive.